Group 2, the alkaline earth metals. So the first thing we're going to have a look at is their electron configuration. So to do that, we need to look at where we find them in the periodic table. So if we go back to a periodic table, we can see that the group 2 metals are here. These are the alkaline earth metals. So they're in group 2. That means they have 2 electrons in their outer shell. This is the S block of the periodic table, this section here. So they're going to end S2. Beryllium is element number 4, magnesium's number 12, calcium's number 20, strontium 38, and so on. So we can use that information to work out their electron configuration. So if we have a look, so we said beryllium was element number 4. And so we're going to start at the beginning, put in the first shell in the S subshell, 2 electrons, move to the second shell to the S subshell, and we'll also place 2. It ends S2. And then we said that magnesium was element number 12, so we start in the first shell to the S subshell full, the second shell, fill the S subshell, move across, fill the P subshell, that's the first 10, third row, third shell, S2. Now, to save us carrying on writing everything out, we're going to use the shorthand. So just a quick remember of what the shorthand was about. If we were to consider magnesium, what we want to do is look at the noble gas that comes before the element we're interested in. So we're looking at something that ends P6. So if we go back up to our periodic table, and we're considering, we're looking at magnesium here, number 12, we go back. Go up a row to the noble gas that comes before, neon. Neon has 10 electrons. And so we're going to say that magnesium's electron configuration is the same as neon's with 10, and then we've just got the last little bit, 3s2. So if we're going to do that for calcium, so if we have a look, we look where calcium is on the periodic table. Let me just zoom out a bit. We've got 20 electrons. We go back to the noble gas that comes just before it, argon, with 18. So we're going to put argon in square brackets, and then we're in the 1, the row with hydrogen and helium, 2, 3, 4th shell, S2. So we're going to follow on that pattern. So going argon for S2, and then the next noble gas would be krypton, and then we're in the 5th row, S2, and then xenon 6s2. So what we can see is that every group 2 element ends S2, 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 S2. 2 electrons in the highest energy subshell, and that's the S subshell. So other properties that we can say of group 2, we've got melting points. So what would we expect their melting point to be? So they're metals, so we'd expect them to have a high melting point because metals are a giant metallic structure. So they're giant metallic lattices. It means we've got lots of positively charged metal ions in a regularly endlessly repeating lattice structure. So these are all, because they're in group 2, these are all 2 plus. And then each one of these has released 2 electrons into the sea of delocalized electrons. And it's that force of attraction, be careful to say what the attraction is. It's a force of attraction, not a force of repulsion. Force of attraction is going to be strong. So we have strong forces of attraction, and then we have to quote what metallic bonds are between positive metal ions and delocalized electrons. These take a lot of energy to break. Our next physical property is their density. Remember that density is mass per unit volume. And we're just going to compare them to the other metals nearby, the group 1 metals, and we say that they are harder and have a higher density. And that is because group 2 ions are smaller than group 1 ions. They have the same number of protons. So if you were to compare sodium 1 plus and magnesium 2 plus, sorry, they have the same number of electrons, but an Mg2 plus has more protons holding on to those electrons, so sucking those electrons in. So because they're smaller, therefore they pack more closely together in the metallic lattice. Okay. Reactivity. Group 2 metals are all reactive and they all have similar chemical reactions. Why does anything in the same group have a similar reaction? It's all because of outer shell electrons. So they all have 2 electrons in their outer shell, i.e., they all have the same number of outer shell electrons. And the last little thing on this page is to ask us about what the appearance of the compounds. So this is not of the group 2 metals, so this is e.g. something like MgO, calcium carbonate, barium chloride. These are all white, ionic, crystalline solids. So just like salt, they've got that similar crystalline structure.